My talk today comes from my experience in modeling scenarios for COVID-19 epidemics and from the realization that some ethical framework was needed even in order to decide what to analyze and how to present it. Epidemic model can be nowadays much more complex than in the past, thanks to data like mobility or social interactions that are available. Thus, it is possible to follow the evolution of an epidemic or a pandemic inside groups, inside population, inside regions, and this leads us to have a very precise understanding of who is affected by an epidemic. One of the main objectives during an epidemic is to reach the so-called herd immunity threshold, that is to say, a situation where epidemic stops. Usually, this is associated to a single number, to a certain fraction of people that must be vaccinated in order to reach the herd immunity. However, in the case of a complex modeling, the choice is not anymore unique. As an example, in the case of a model that considers two classes to be vaccinated, the herd immunity is a continuous line separating a region where the epidemic will spread to the region where the epidemics will dampen out. In the slide, we show in green the region where the population is safe, in red the region where the epidemic will spread, and you can see that herd immunity is a continuous line. Thus, mathematically, herd immunity does not correspond anymore to a single threshold, but for more than two classes to a continuous surface. Here I present the results for a model with realistic COVID-19 propagation parameters and vaccine efficacy. In particular, we are minimizing the number of deaths, and we are considering the fraction of vaccines to be given to each population respect to the vaccine availability. Obviously, for low vaccine availability, no herd immunity can be reached. Notice that due to the fragility of the elderly population respect to COVID-19, all the elderly population is vaccinated. On the other hand, we notice a crossover from a situation where with low vaccine availability is better to vaccine younger people since they are strongest spreaders, to a situation where with enough vaccine availability is better to vaccine more middle-aged people since their mortality is higher. Obviously, these heterogeneous policies are always better than homogeneous policies where I vaccine a certain fraction of people irrespectively of their class. However, it depends a lot on what I choose to minimize. For example, if I choose to minimize the life expectancies, the distribution of vaccines could be different. Hence, even deciding what to minimize contains strong ethical implications. Notice that for a fixed vaccine availability, the three allocation of vaccine for elders, medians, and youngs correspond to a point on the herd immunity surface. Analogous considerations apply in the case where we have to resort to non-pharmaceutical interventions due to the lack of a vaccine for a newborn epidemic. As an example, we can modulate the lockdown intensity per class along a lockdown immunity surface that defines the intensity of lockdown able to stop the epidemic while we wait for the vaccine. As an example, we show a case study where to sustain the economy we have several strategies of lockdown only for young or elderly classes. Due to social interactions, the lockdown on these two classes has a positive impact also on the middle-aged class that represents the working force. However, it is a situation where the working force has a higher probability of getting infected and youngs and elders gets a lot of psychological stress. Again, ethical questions arise not only in deciding what scenario is best, but also in which scenarios to analyze one has to choose. In general, ethical frameworks help us to take decisions while accounting for several ethical principles. However, in a complex situation, even a single principle will not correspond to a unique and univocal way of deciding which scenarios are the best one. Moreover, since simulations and scenario analysis show us that improving a dimension normally makes another dimension worse, having multiple principles can lead to a paradox in the sense that trying to make something better makes something else worse. Last but not least, while in the medical community there is a very advanced and purposeful discussion on ethical frameworks and ethical implications, the point is that during the last pandemic, the decisions have been taken by politicians that, at least in Italy, are not only not used to consider ethical assessment of their decisions, but often have no expertise in understanding the consequences of complex models. A perfect example are the Italian COVID-19 decrees that were totally ignored since there is no culture in reading risk tables or reading an algorithm. In conclusion, data-driven models of a complex system are multifaceted. Therefore, they introduce a possibility of choosing metrics and selecting scenarios, but this influences the following decision-making procedures. Thus, data-driven policies are strongly influenced from the build-up of the models and the reading of the data that scientists can do. Moreover, this kind of detailed modeling uncovers all the imbalances there are between gains and losses of single groups, and so can even promote conflicts among the actors. Finally, having so many choices makes ethical evaluation a particularly complex process, requiring a careful evaluation of ethical consequences in all the phases, from the build-up of the reports by the scientists to the decision-making of the policymakers. Thank you for your attention.